We're continuing our exploration of stoichiometry and the burning of xylene. Activity 1, which was the previous video, we came up with a balanced equation and used it for several other things. We're starting fresh, but this is the amount we're starting with here, 14.61 grams of paraxylene. So eventually, we're going to be converting that to something. But let's look at steps. Balanced equation done. Formula weights for all relevant molecules. Okay. Hey, formula weights synonymous with what? Molar mass? Yeah. So we need formula weight for the relevant molecules. Now, guys, I tell you what they are in this question, what they are, but you need to tell me what are the only two chemicals I'm asking about in this question. Yeah, p-xylene and grams of carbon dioxide. So I need those two formula weights. If they're mentioned in the question, please give me their formula weight. So FW, C8H10. I'll do it again, you know. Where do I get the numbers to do this? Periodic table. And what are the units of these numbers? Grams per mole. We cracked the 10 barrier. And hydrogen, 10 of them. Times the molecular weight on the periodic table. 1.008. And what are the units of those numbers on the periodic table? What are the units? That's a description of it. Grams per mole. There you go. And what do you got? I got 160, 170. It's in the 170s. What'd you get? Oh, don't give up on me. Can you do it? 96.08. Oh, grams per mole. Okay. And we also need carbon dioxide. We did it before, but let's do it again. 12.01. What are the units? Grams per mole. That's another ticky. And we have CO2. There's two O's. 2 times 16.00. What are the units? 16.00. You got it from up there. What are the units? Yeah, I know you're getting tired of saying it. That's good, but I still need to hear it. That's two more. Yeah, let's make sure it's clear.
96 is just a carbon.
Oh, somebody gave me just the height of the carbon. Okay. Yeah, 96 plus 10, 106. I don't know where my estimate came from. It was way off. Bad estimate day. What was the actual? Okay, I'll go 106.2. 4 sig figs, anything on the periodic table, 4 sig figs, you'll never be in trouble. And this one was 44.01. I remember from the previous one. What are the units though? Grams per mole. Can't get that wrong. That's why we keep asking about it. Yeah. Okay. So the question here is, if 14.61 grams, that's not moles. You are reading the question, you're not ready to use the coefficients, right? Reading the question, you know you can't use the coefficients because it doesn't say moles. Coefficients are only good for what? Moles of substance A to moles of substance B on the balanced equation. We do want to do that, but we can't yet because we don't have moles. Step 1, go to moles. Go to moles, grams to mole. That's such an important skill. I don't even have steps for it because you have to just ingrain it. You got grams, something that gets rid of grams, C8H10, and gives you moles, C8H10. Okay, I got the work done above, but it seems to have the wrong unit on top. It's got moles on top, grams on the bottom. No big deal, right? Flip it. 106.2. Notice he said flip it. You can tell when somebody's buying into dimensional analysis. They never use the divide word ever. Do not use the divide word. Multiply by a conversion factor covers everything. And that's what we're doing, right? Okay, and I'm bad at guessing today, so I'm not going to guess. What? Did I do halfway decent job? Wow, that was a lot of numbers. Yeah, I got a 0 in there. I snuck it. And that's going to now be mole. C8H10. Did it ask? Is that the question? No. It says go to moles. Then stoichiometry, convert moles of p-xylene to moles of carbon dioxide. You can't see the 2 there. Yeah. Moles to moles. Hey, that's coefficients. That's stoichiometry. Let's go. We could have done this in one line. You know that, right? Moles C8H10. Purple. Once you got moles of one substance, what's the time for? And what's the other substance we need? How many grams of what can be produced? CO2. What's the relationship between moles of CO2 made for moles of C8H10 reacted? 16 made CO2s for every 2 used reactants. And these guys are gone, and you're at moles. And give me a nice number with lots of decimals. 10% of 16 is going to be more than 1.
1.10564970.
There you go. Not quite there yet, but we're real close, aren't we? How many grams of carbon dioxide? Okay, we got moles of carbon dioxide. Now, moles, grams, grams, moles, moles, grams, grams, moles. Every time you're asked to do that, where do you get the numbers? We did the work already, but where did I get the numbers? Grams, moles, moles, grams, periodic table. We did the work up here. It's the grams per mole information, right? Now I want to go mole CO2 to gram CO2. And I got to use this one, right? Boom. Yeah. So don't use that pen on the screen. That would make marks. 1.100564972 mole CO2. 44.01 grams CO2. Every 1 mole CO2. Bye-bye. Bye-bye. And is it, what's 10% of 44? 49-ish? 48.435. And that's grams CO2. Now 4 sig figs. There's a final answer. And of course, I want to show you how we do this problem in one line. Because some people, they're ready for that. Okay? And they should be rewarded. Doing extra lines is not a punishment. It's just step-by-step process. It's good thinking. So talk to me about going from here to the end and writing it out in pink. 61 grams C8H10 times 1 mole for 106.2 grams times 16 moles CO2, 2 moles C8H10. You're done with C8H10, aren't you? No longer talking about C8H10. Grams C8H10 is gone. Let's be more careful with our thing. The grams is gone. Now it's moles C8H10. See how I read that? When I'm done, moles of C8H10. I'm canceling moles of C8, moles of C8. Now I'll do it in a different color. I just want this to be clear. Moles of C8H10 cancels moles of C8H10. 1 second, almost there. Times 44. We're going to get the same answer, ladies and gentlemen. 44.01 grams per mole. And that's grams CO2 per mole CO2. And canceling that with baby blue again. And we had a question over there. Uh-oh, which one? This one? Yes, 48.44. Thank you. We fixed that before we publish, right? 48.44. I rounded wrong. Thank you for patiently waiting too. Okay, and there's the whole thing in one line. If you get comfortable and you can get to that, that's great. If not, follow my steps. Now, for this problem on the test, these steps are going to stay. These words, I'm going to copy paste. I'm going to give you a new fuel. That's it. That changes everything right there. New fuel, that's it. Be able to do everything I did with activities 1, 2, 3 on test day. Promise? Big chunk of test. Big problem. And I think that's the end of the video. That's all we wanted, right? Grams of carbon dioxide. And before I leave you, the theoretically is not an accident there. Theoretical yield is the most stuff you could make. In reality, in life, we do a reaction, we never get quite as much stuff as we could have got. Not every molecule reacts. Some molecules get lost when you purify things. There's lots of reasons why you never get 100%. Okay? So theoretical yield is the most you can theoretically, in your mind, make. And then you go in the lab and you actually make it, and then you compare. So that's our next exercise. It's not a big one. Yeah, here we go.